Okay. All right. Well, as we already established, my name's Tim Hess. Thanks again for joining me today. I am a software engineer in the Tanzu division at Broadcom, and I'm excited to talk to you today about building cloud-native .NET applications with Steeltoe. And let's get into it. Just a little bit of background about this project. For those of you that don't know anything about it, Steeltoe is obviously an open source project. It's been developed primarily by employees of a company called Pivotal Software, which later became VMware, and is now part of Broadcom's Tanzu division. Um, the core mission of this project has always been to reduce developer toil by providing modern and cloud-native features that are reliable and easy to use so that you can focus on what makes your applications unique. And more specifically, and a reason why I give you the corporate history, we are a member of the same organization that maintains the core Spring projects for the Java ecosystem. And one of our goals is to bring some of their productivity wins to .NET developers. Now, if that sounds odd to you, just consider that Spring has been solving cloud scale problems for a very long time now. And some of the popular open source options for things like configuration management, service discovery, and application management have been quite well tested. So why not allow those .NET developers to use those same options, especially for organizations that are using both Spring and .NET to build their apps? Steeltoe has been open source under the Apache 2.0 license since 2016. That means it's built with and for a community with all the transparency and collaboration that open source brings. We have no intention of changing that. This framework has evolved significantly over the years, and with our recently released 4.0 version, we've made it feel more .NET native than ever, while still offering the same familiar features and interoperability with Spring projects where it makes sense. So speaking of that 4.0 release, I'll just spend a minute on what the big deal is. This has been a very significant release for us, and it's a major step forward in a number of ways. First of all, it requires .NET 8 or above. This move allowed us to take advantage of some of the latest features in .NET and the performance improvements, and it ensures that we're all building on a modern supported platform. As part of that move, we updated all of our dependencies to their latest stable versions so that we're getting the best security, performance, and compatibility with the .NET ecosystem that's available today. And one of the biggest improvements in the framework itself is cleaner, more consistent APIs. We conducted a comprehensive review of our entire public surface area, enhanced XML documentation, particularly in places where it was missing. We eliminated duplication, and we improved the clarity. Now, if you think about it, this is an open source project that's been in development for almost a decade. There's a lot here. There's contributions from a lot of different people. So we took a step back and we tried to clean it all up and make it much more consistent. In the process, we dramatically reduced what's publicly accessible so that it's clearer where you should and shouldn't try to hook into it, and so that we can evolve the framework internally with less of a risk of breaking your code. We've also improved our own tooling so that our builds are faster and catch more issues, and that we will push out fewer breaking changes going forward. We've also embraced a number of modern .NET features, some of which were not even around when Steeltoe was originally written. I'm talking about things like nullable annotations throughout the code base, so there are fewer null reference exceptions. We're using options in more places so that we have easier runtime reconfigurability of the various components. And we've removed some of our own abstractions that were duplicating some of the functionality that's offered in Microsoft's libraries. We're also now embedding JSON schemas for the configuration of the packages directly in the packages themselves so that you get IntelliSense and validation right in your IDE when you're editing app settings.json files. And we've also embedded the debug symbols in the packages so that you can step directly into the source code if you ever need to. Finally, we did remove some components that were either rarely used, had better alternatives, or just weren't maintainable with the capacity available on our team. So these changes were primarily affecting components that interacted with the Kubernetes API and also the messaging and stream components, which incidentally I was very sad to remove. They barely had a chance to get off the ground, but the messaging and stream components in particular were still very, very Spring-like. And when we removed them, it was about 150 lines of code. The guy who built that for us ended up retiring, so we just had no ability to continue maintaining it. So we just had to cut it out. The result of all these changes, though, is a much leaner, more focused framework, and we have an easier and safer path forward for providing updates in the future. So what does Steeltoe actually provide? I'll give you a quick overview of the components before we actually dive in. Configuration is one of the most popular areas of Steeltoe. We provide several configuration providers that all plug into iConfiguration. We also offer connectors, which are for transforming cloud credentials into connection strings for databases, message queues, and a bunch of other services. We also have service discovery, which of course allows you to register your services or find and connect to other service instances on the fly while you're running. We offer features for application management, which is primarily HTTP endpoints that are compatible with actuator endpoints that Spring Boot offers. This is for things like refreshing your configuration, performing health checks, managing levels, taking memory dumps, and more. And we also have several packages related to application security. So, more specifically about configuration management. One of the fundamental principles of cloud native applications is that your configuration should be separate from your code. So, you shouldn't have to change your application code when you're moving from your local system to your test environment, your staging environment, and into production. Only the configuration should be changing. And all of the Steeltoe configuration libraries are built as iConfiguration providers. So they're very natural to use from .NET. You can use the same patterns you're already familiar with, whether that's reading the values directly from iConfiguration or using the options pattern. The demo that I'm going to run through in a moment is going to use the Spring Cloud Config Server for centralized configuration management. The config server is one of the most popular components in the Spring Cloud ecosystem because it allows you to simplify and centralize the configuration for distributed applications. And config server itself includes far more features than I actually have time to cover today. So if it sounds interesting to you and it's new, just know that we're only scratching the surface. One of the core features is conventions in config server. And as I'm sure you already know, .NET apps are always going to start with an app settings.json file. And then we have the app settings.environment name.json convention, where the environment name aligns with ASP.NET Core environment. Config server has that idea too, and Steeltoe actually hooks into the same ASP.NET Core environment to automatically integrate with it. But since config server is built for distributed applications, there are additional conventions that make it easy to keep a number of applications, even across a number of different technologies, in sync while maintaining a single source of truth. The config server supports multiple file formats, and you can organize your files by things like file name, environment name, or several other patterns. The most common way to use this config server is with a Git repository, so you can store all of your configuration files in a version controlled place, and you can keep track of all those changes and know exactly what changed when and how. But then the config server will distribute those values for all of your apps however they need to get refreshed. Steeltoe also supports several more fairly powerful configuration providers. We have a placeholder provider, which you can see an example of in this slide. We've got this $ curly brace format where you can embed some other configuration key, and you can actually daisy chain them a bit. So you could have multiple fallback values and ultimately some default value if none of the config keys were found. We also have this Cloud Foundry environment variables provider for parsing VCAP application and VCAP services for integration with Cloud Foundry-based platforms. Just as a quick aside here, I'm probably going to mention Cloud Foundry several more times today. If you don't know what that is, that's okay. You don't need to know anything about it to use Steeltoe, and you don't need Steeltoe to use Cloud Foundry. It is a platform that's near and dear to me, though, and I think it's one of the best places to run Steeltoe enhanced apps. But moving on from that, we also have a random value provider for generating things like random strings, numbers, and GUIDs. It can be used particularly effectively with the placeholder provider. We also have a decryption provider, which is compatible with a Spring Boot system. And so the idea there is you might have configuration values that are stored encrypted, and then your Steeltoe app or your Spring Boot app is going to read those down and then decrypt them while the app is running. We also have a Spring Boot configuration provider, which is there to provide compatibility for several other Spring-related scenarios that we're not going to get into today. All right, let's talk about this demo app. I'm going to be running several demos today out of one distributed application, and it was built from the Aspire starter app template. I imagine most of you have already seen that before, but you can tell from this diagram that it's a little bit more complicated than the standard front-end, back-end scenario that comes in that template. So in this app, we've obviously got the standard front end, the .NET Web Service back end, but I also added a Spring Boot API that, for the simplicity, does the exact same things that the .NET API does. But we added a Spring Cloud config server, a Eureka server, and a Spring Boot admin server for showing what actuators can do. And obviously, all of this is going to be orchestrated with Aspire. And of course, related to that note, some of the APIs that I'm just going to kind of hint at today aren't actually public yet. We haven't released anything in the space because this Aspire integration is still a work in progress for us. So you're going to see some code that you can't quite use yet, but everything that you can use is still easily achievable without the Aspire orchestration. So let's go take a look at what this actually looks like. That's the wrong one. All right, here's my app host. We're building a distributed application, and I don't think that's sharing what I wanted to share. Let's try that again. There we go. Maybe. Kevin, come back. My screen share broke. There it goes. Okay. Okay. One more time in the app host here. Building a distributed application. And these several of the experimental methods. We're just spinning up some container images here. And all three of these examples are going to be Steeltoe development images. We produce these images so that we can develop Steeltoe. These are not production ready images. They just support the core functionality that we need to do our jobs. In the case of config server, Eureka server, and actually the Spring Boot admin server, they are just plain old Spring apps that have a package reference to whatever it takes to make that particular server get up and running. In this case, well, I'll come back to it. So we also got our API service that we're building out here. We have the Spring app and the web app front end. Back to the config server specifically, I'm pointing it at a local folder to read these configuration files. And inside that file, it's just YAML. So this is our standard weather API summary options. Really basic example. But in terms of how that's actually used in an application, we'll take a look at my API service. And in terms of adding the reference to the config server, it's really just one line of code. In this case, we're doing something fancy here where we're passing in this logger factory. The Bootstrap logger factory is something that we provide as part of Steeltoe. So we're doing this config server configuration provider. If you've ever worked with configuration providers, you may know that the logging subsystem isn't available yet. So we just have this Bootstrap logger that has a basic configuration that will spit out console logs and debugger logs. And it's just a nice, easy one-liner so that you can get logging out of a configuration provider when you wouldn't otherwise be able to do that. For this app, with the configuration that we're reading out of config server, we are binding that weather options that we saw in the application YAML file to the weather options class, which if we go take a peek at that definition is a nice basic, just plain old .NET. It's a list of strings. And then in terms of how we're actually using that, we're injecting an iOptions snapshot so that it reads from configuration on every HTTP request. And we're just using a random selection of those summaries to produce our extremely reliable weather forecast. So what does this actually look like? And of course, we're doing something similar on the Spring side, but I'm not demoing Spring today, so we'll just forget about that implementation detail. Let's take a look at what this distributed app looks like from the Aspire perspective. You can see all of our individual components here are up and running. We got our 3 infrastructure services, and we got our 3 app services. The UI for this web app is, of course, your standard Blazor interface, and here we're getting a weather forecast. Nothing particularly unique if you've seen any Aspire demo in the last couple of years, but here it is. Let's see where the power of this config server comes in. If I go back to the file that's serving my configuration, Application YAML. There's a few options here for the forecast, but we're approaching winter, so let's just get real negative about it and just say, you know what, I don't care what the forecast maybe should be. It's freezing. It's always freezing because it's getting colder, so it's always freezing to me. My configuration, the config server is already up to date. I can see I got this handy link here for the default config. I talked earlier about some of the conventions that are available. The default settings will appear to any app that connects. When you're reaching config server, the path for the configuration can be things like your app name and your environment name. That's typically how the Steeltoe client is going to work. So we can see that any application that connects, regardless of what environment name it uses, is just going to get this one setting for freezing. Let me just switch that back real quick so that you can see what it all looks like. Boom, all the summaries. So nice, quick, instant update there. No surprise, that's not particularly fancy. Where things get interesting is how our apps get those updates. In the case of the Spring app, I don't have anything hooked up that it would receive the app in real updates in real time. So it's still got the old values here, right? So just double checking. Yep, it should only say freezing if it's getting the latest config data. It's not. If I look at my .NET app, which was again using the iOptions snapshot, that in and of itself isn't enough to get the latest versions. It is all updated to freezing, but why is my .NET app updated and my Spring app isn't? Well, we have a neat little feature in Steeltoe that I activated with the config setting here. We set it to pull the config server every 10 seconds. You probably don't want it to pull every 10 seconds. If you imagine, maybe you've got 100 app instances in your environment. If they're all polling the config server every 10 seconds, that's a lot of traffic. So there's a different pattern that you can use, and that is to use something like the refresh actuator, which we'll get into the actuator details different later. But just real quickly, we have a quick little option here to refresh configuration. So that'll do an HTTP request in the background to go get the updated configuration in the Spring app. And now when we do that update, it's up to date. So depending on the different strategies you want to use, all of the different apps can get that updated configuration in their own time. Okay, that is enough about config server. Let's get back to some slides here. Talk about what's next. Steeltoe connectors is the next component area. I don't have a demo for them in this talk today, but they are still a valuable part of the Steeltoe ecosystem. The purpose is to automatically transform cloud platform credentials into connection strings. So the idea is that when you run on Cloud Foundry or some other platform that offers a service binding implementation, a relationship is formed between your app and the backing service called the service binding. And generally, you're going to get credentials that are unique to that service binding so that you can use them in your app. Usually, they're going to be provided on Cloud Foundry through environment variables like vcap services, or if you're using the Kubernetes flavor, there's a key per file style where the file name is the key and the file content is the value. And parsing these values across these various scenarios can be error prone and tedious, but Steeltoe makes it easy and provides one-liners for it to do it all automatically. There's a bunch of different services supported: SQL Server, MongoDB, MySQL, Postgres, just to name a few. But the idea is that we read the service binding, extract the connection information, and provide it to your application through standard .NET interfaces. So it's just all automagic. The next component area is, I completely skipped over it earlier, but the demo does rely heavily on service discovery in order for finding those backing services. In a microservices architecture, you need to be able to find all of your service instances, and hard coding URLs doesn't always work when service instances can come and go, or maybe you want to define your own load balancing policy that operates in the client, or maybe you just don't trust DNS anymore after it's caused too many outages for you. In any event, Microsoft, with the launch of Aspire, did add their own first-party packages in the service discovery space, but in combination with Spring, Steeltoe is providing service discovery and service registration features actually for almost a decade now. With Steeltoe or Spring, service instances register themselves with a registry when they start up, so that other apps can discover the addresses of those service instances using a shared key called the service name rather than needing to know the address in advance. And just like externalizing your configuration, when you use this pattern, it makes your applications even more portable. Actually, with Steeltoe, we offer a feature that is also found on the Spring side that's called Discovery First Configuration that combines these two items. So if you go to the absolute extreme with it, the only configuration that your app needs when it starts up is the address of the service registry. Some of the other features that are key in Steeltoe, well, client-side load balancing, as I already mentioned. We do provide random and round-robin algorithms by default, but we also provide abstractions so that you could write your own least cost routing or whatever other algorithm you can think of. We, of course, have an HTTP client integration so that it's extremely easy to use. And we also provide the facility for automatic registration and deregistration when your app has a graceful shutdown. And we provide support for Spring Cloud Netflix Eureka, which is what we'll be using in the demo, but you could also choose HashiCorp Console, or there is a configuration-based provider, but you probably would only want to use it locally since it's going to be completely static. But it's good for using a registry, for not using a registry, but still using the same patterns. So let's go back to the code and take a look at how this works. All right. Again, we've got this container startup here. You can see in our API service that we're doing this with Eureka registration. This, again, is going to be one of our prototype APIs. It's just doing some basic configuration here. So this isn't the magic of how you actually add it to your app. We've got just a different prototype for the .NET configuration key format versus the Java configuration key format. Looking into an application for how we actually trigger this. It's, again, just a neat little one-liner. Our prototype version for Aspire is here. Without Aspire, it's still just a one-liner. You would just add Eureka Discovery Client. In this case, though, with the prototype, we're saying that I want this application to register itself, but I don't want it to do any lookups. So we can save some background cycles in terms of connecting with Eureka to see what's available. You can choose. A lot of times your apps are going to either register or discover. They're not going to do both. So you can save some cycles by efficiently picking which option you want to use. In terms of actually doing that discovery side, if I click down here into our web front end, this is going to be very, very similar to the standard Aspire situation where you actually have your service name here. This isn't a host address. This is the key for doing that lookup that I was talking about. And one thing that is a little bit funny about this, if I click back in here and show you back to the app host, the standard Aspire format is that you're going to look up by this service name. This demo, like I said, is funky because I'm doing a .NET app and a Spring app. So I have both of my services not registering with these names, which is what's on the dashboard. But in the configuration, I've got them both set to log in with just weather service as their Eureka instance name. So if we go back to our Aspire dashboard here, Eureka has its own handy little dashboard, which, again, this is getting a little bit redundant. We've got discovery plus discovery plus discovery. Whew, gets crazy. But the Eureka service discovery is going to be much more useful for you when you're not running locally. If you're in an environment, well, in any kind of server environment where you want more options than what DNS provides you, or maybe you've got a different multi-data center strategy. There's any kinds of really complicated scenarios that you would come up with. But anyway, we've got here our weather service application, and there's 2 instances of it available. And you can see that I've got 2 very differently set host names here. But ultimately, they're both working, and I can't see it from here. If I stop my API service, that'll get us something a little bit more interesting. We go back to the Eureka dashboard, and it should update pretty quickly. No, not today. Okay. There, okay, it's gone. And then, of course, because of this being built for a cloud environment, there's some additional caching that's built into the service discovery client. inside of Steeltoe, so that, for example, if the Eureka server were to go away for 30 seconds, all of your apps wouldn't go down, because they maintain their own local copy of this application list. We go in here, and all of this is still working, even though half of my service instances are now gone. If we go take a look at the traces, that's another way to see what's going on here. I'll filter this down so that we don't see all of the unrelated requests. We can see now this one's on me. In my demo, I didn't get the Spring app to send its traces correctly to the dashboard, so you can see pretty instantly at a glance. This one went to the .NET app backend. This one went to the Spring app backend, and all of these recent requests are going to the Spring app backend. So if we fire that instance back up again, it'll show up on the dashboard pretty quickly. And then we can initiate a few more requests here. And back to our traces. Filter it back down again. And you can see that we're getting 50-50 between Spring and .NET again. All right. Did I miss anything there? Nope, I think that's all I wanted to cover on that. Clean out some of these tabs and kick it back into the slides. Okay, that's service discovery. Let's talk about application management and monitoring. Steeltoe provides Spring Boot compatible actuators. Now, these are endpoints that, for our purposes, are exposed over HTTP that give you insight into and control over your applications. We only offer over HTTP. Spring offers over the JMX protocol as another communication option for interacting with these actuators. We originally built them with the idea that maybe at some point you could do other abstractions, like maybe you wanted a RabbitMQ actuator interface. That hasn't really happened. There isn't another client that exists for the front end. The only clients that I'm aware of for reading actuators are HTTP based, so that's just what we're sticking with. Today in Steeltoe, we offer around 13 different endpoints, but we also have some abstractions available so that you could add your own actuators. So there are some that exist on the Spring side that don't exist on the .NET side. It'd be great if we got some contributors out there that said, I really want to see the sessions actuator and I absolutely want to make it happen. That'd be great. Come on in and see if you can help figure it out. But for the actuators that exist today, one of the most popular is for dynamic log level management. I'll show you this in a minute, but the idea here is that you can turn individual loggers off and on, just like you would normally do with the app settings.json file, but now you can do it with an HTTP request. And so obviously you don't have to restart your application or anything. And you can very quickly tune those logs up and down. We have an info endpoint that quickly lets you get application metadata, like get commit info, build version, or we also offer an iInfo contributor interface so that you can determine anything, whether it's static at build time or something that updates dynamically while your app is running. And it can contribute that to the endpoint. We also offer health checks, which isn't anything new for the .NET space. We have our own interfaces that existed before the other .NET health check interfaces, but we do also read the Microsoft health check interfaces as well, and we can output them into more of the Spring output format for things like Spring Boot Admin and various other things. We also offer heap and thread dump endpoints primarily for debugging production issues, so you can just do an HTTP request and you can find out what's in memory in my app. We have a refresh endpoint that I showed briefly earlier with the Spring app that triggers configuration reloading. And obviously you can pair that with config server if you want to take full control of when your configuration gets refreshed. In a minute, I'm going to show you how these actuators work with Spring Boot Admin, which is yet another open source project that provides a web-based UI for aggregating the actuator endpoints from multiple applications so that you can go to one single dashboard, just like with the Aspire dashboard, but you can manage all of these services running in any environment and interact with their Spring Boot compatible actuators. Ideally, in the future, I'd be okay with not using Spring Boot Admin in the future. The only reason we do it is for local development with Steeltoe. I'd much rather see an integration in Aspire for working with these endpoints. And so hopefully we can get to work on that pretty soon. Separate from actuators, still in the management space, we also offer some other abstractions for doing administrative tasks. These are going to be triggered at startup through command line parameters. This feature was, again, built for Cloud Foundry specifically. There's this option called CF Run Task, where you can trigger this alternate endpoint into your application and do things like database migration. So, for example, if you're using Entity Framework Core and you don't want your database migrations to process automatically, you can make it so that you have to run this command and it will go read the database and update the schema accordingly. All right, so let's go see what this actually looks like now. All right. I should probably show you the code first. Again, nothing useful in the addition of the container itself. I do have this, again, prototype endpoint that sets just a bunch of configuration flags. Because these management endpoints can deal with some highly sensitive information, we do tend to operate them as secure by default. So you have to tell Steeltoe that, okay, I already added them to my application, but I do actually definitely want to expose either some specific list of the endpoints or all of them. For the purposes of what we're trying to do with Aspire right now, it's a local development experience, so it should be safe-ish to have all of that just exposed without any kind of security on it. So we just say, yeah, go ahead and expose everything. And when it comes to health, show me all of the components that contribute to health, show me all of the details. And then these are just a couple of health groups that are available with that endpoint. And then, of course, like I said, this is all prototypes, so we've got terrible names. If I don't want this with actuators thing to always configure the Spring Boot admin client, but that's just what it's doing for today. In terms of the magical bit that actually adds the actuator code to your application, it's, again, going to be a non-dramatic one-liner. It's just add all actuators, and then it goes ahead and it adds all of those actuator endpoints and all of the underlying infrastructure to the DI container and wires that all up for you with the HTTP middlewares and everything. And then there is a separate one-liner to add that Spring Boot admin client. Okay, so let's actually look at it while it's running. Like I said, there's a web interface. We can see that I've got 3 different services registered with it. If we look, let's just take a very brief look at the Spring app, just so you can see the thing that was built for the thing. You get a whole bunch of information. Well, they don't have any info here. That's probably my fault for not setting something up. But we've got a health response here with a bunch of different components, and you can see detailed information. Again, this is probably nothing new or revolutionary, but it's cool that you can activate it with a single line of code, and all of this just lights up. But there's a bunch of things here. You're going to see more things on the Spring side than there are on the .NET side. But I'll click over here and we'll go take a look at one of these .NET ones. This is the Steeltoe weather service. So this is that API app that we've been looking at. You can see there's Git information. So this is just set by MS build properties to read in that Git info, spit out a Git.properties file. But at a glance, with my running application, you imagine this running in production. You're like, well, is the version that I think is running there actually running there? Well, this will go ahead and give you the actual commit shot and even a timestamp. And, in case there was any doubt, you can confirm what repository it came from, things along those lines. Again, we've got the health information over here. Let's look at a different actuator. The ENV actuator is a really useful one for debugging what's going on with your configuration. This, in the Steeltoe implementation, will break down your configuration based on the provider. So I can see that we had an environment variables configuration provider that found that this is the development environment, this is the URL you're supposed to run on. And then because this is that layer cake model of iConfiguration, all of these kind of stack in order. So this is our base layer, and then everything that comes down below is overriding it. So you got app settings.json is telling me that, oh yeah, when you connect to the Eureka instance, this is your app name. And it all just kind of stacks on from there. I don't know if there's anything else interesting in this particular example, but it's a really cool way to debug what's going on with your different configuration providers. The beans actuator is not a good name at all for .NET. We like to call this the services endpoint on our side, but again, going back to the Spring Boot compatibility, in order to get something to show up in Spring Boot admin, we're showing it under beans. But this is all the services that are registered in the DI container, and you can get an insane amount of detail here, like the name of the thing. Well, this isn't a good example. Let's find another one. Some of these somewhere have dependencies. Yeah, this one. Okay, so whatever that ridiculously long thing is, has a dependency on an iLogger provider configuration. And so if you've got issues with certain things not working right, this is another way to dig into it and figure out what's going on. The loggers actuator is, again, one of the most useful. I was doing something with Eureka earlier, and so I actually, if I were to go look at the logs and the other thing, we'd probably see that there's a bunch of, you know what, that was my other app. There is a bunch of detail in the loggers, and let's imagine that my application is running in production and it's filling up the logs because there's just too much data coming out. You go in here and you search for that namespace that in this case was a problem. And look, you can see that everything in Eureka was set down to trace. Well, you know what? My Eureka setup is good to go. And I know that I can turn it back down to trace if I need to later. So for now, I can just say, boop, that's off. I don't want those Eureka logs, and they'll just be totally gone from the output. So you can see here that we were dumping a ton of Eureka logs here before, and that should stop now. So that's one of the interesting use cases for that, the loggers endpoint. There are some additional diagnostic things that we can do. I mentioned earlier heap dumps and thread dumps. I'm not going to do a heap dump and diagnose the memory issues or anything like that here, but this is kind of a neat view of the running threads that your application has. So again, you can drill down into it and find out, okay, here, what is this thread doing? Well, it's our OpenTelemetry batch exporter. That's kind of cool. Lots of different things you can do with it and get all kinds of different insights to, what happened right here, whatever the case may be. Okay. Also, we have a mappings actuator. So this, you can see, like, these are all of the different things that can respond to HTTP requests. You can see whatever this error page is, probably because this is a Blazor app. It responds to GET and POST requests. So this shouldn't just be a nice, convenient place to go to find out, like, what does this application respond to? There's also the HTTP exchanges. So this is all the things that came into the application and how the application handled it. You can drill down and see, oh yeah, what was my response? This was a 200. And we've got, protections on this. So you're not accidentally logging sensitive data. And I think this is the ones that do show up, I think were explicitly whitelisted, but all that's configurable. Okay, that is a lot about actuators and Spring Boot. Let me just take a quick peek at the chat here. We got any good questions here?
No questions at the moment. Okay. I've asked folks, but yeah, no questions. So keep going.
Okay, I see this. There's one about expire any template curl of array. I don't know exactly what that is, but I will say that we do have some .http files for the actuators that are available as well. I don't think I included them in this particular sample, but if you're interested in such a thing, if you go to the Steeltoe samples repo, which I think I have a link to this at the end of the presentation as well. We have samples for every one of the Steeltoe components. And for example, if you drill down into the management one, there is an HTTP file here. And this has all of the actuators that are supported with some example requests for how to interact with all of that. So going back to that loggers example, if you wanted to change the log level, the HTTP thing that happens here, you just do a post request to the loggers endpoint with the namespace or the logger name that you want to change and the level you want to configure it to. So it's pretty easy to work with. But okay, that is probably enough about endpoints. I'll time check here. I better keep clipping along here. The last major Steeltoe component that I wanted to discuss, I don't have a demo for it today, but it's Steeltoe Security. It's primarily focused on Cloud Foundry related technologies, so it's going to be probably pretty unfamiliar to most of you, but it's really useful in the Cloud Foundry space. So there's this thing called UAA, which is called the User Account and Authentication Server. It's kind of the core of authentication on the Cloud Foundry platform. But on top of that, there's this SSO tile. We just provide some extensions that customize the ASP.NET Core security libraries to work with SSO, for OpenID Connect, and JWT. We also offer a specialized flavor of certificate authentication. This, again, is a customization of the ASP.NET Core library, but Cloud Foundry provides these application instance identity certificates. Every instance of every application that runs on Cloud Foundry is automatically provisioned with a certificate. And these certificates are rotated every 24 hours, and they include some metadata, including what org and space the app lives in. So if you're running on Cloud Foundry, you can do very simple, this service is authorized to make this call kind of checks with it. And then we also have a library for extending the Microsoft data protection libraries to work with a Redis or Valkey instance that was provisioned on Cloud Foundry. Okay. Outside of all of the core components, we do also have something that's inspired by the Spring Initializer, which is one of the things that made Spring Boot incredibly popular. You can go to start.spring.io and get a project that's pretty much guaranteed to work. And now that might seem a bit foreign to .NET developers. We love our .NET templates. They're extremely powerful, and .NET has a bunch of them out of the box. So it might not make the most sense at first, but the idea is not just, oh, here's a basic thing. It's the combination of things that make a template valuable. And with all the success that we saw on the Spring side, we wanted to have it for the Steeltoe side. So we do have start.steeltoe.io, which is the Steeltoe initializer. And the front end of it is just a fork of Spring Initializer. But then we have a bunch of services behind the scenes that work with a .NET templating engine to make it all work kind of similarly. And because we have it all based on a .NET template, you can use it with .NET New or any IDE like Visual Studio. So like the Steeltoe template itself isn't necessarily that revolutionary, but the idea is that you can fork it and make your own customized version that embed your organization standards, your preferred dependencies and versions, your best practices, and even your own internal libraries, if that's what you want. It looks like I'm a bit short on time, so I'm not going to do a demo on it. But if you want to check it out, it's just start.steeltoe.io. And one of the reasons that I like to use the Spring Initializer is sometimes with the Steeltoe work, I need to do a thing in Spring, and I don't really know how. So I just go to start.spring.io and pick the things that I know that I need, and I can see what it spits out. So it's like, well, I just want to take a look at the pom.xml file. And you can see the changes between different versions of the runtime or the Spring Boot versions or whatever it is. And you can just go at a glance, see what changes if X, Y, or Z without having to spin up a whole new project. Or, maybe you do walk through those steps and find out this is exactly what I need. Let's go ahead and let's build it. Honestly, that's actually how we build the Docker images that we use for Config Server, Eureka, and for Spring Boot Admin. It's an incredibly easy way to get started, especially if it's something you're not particularly familiar with. Okay, skip the demo. Just kind of a note here. Previous versions of Steeltoe were built for older .NET Framework stuff. So .NET Framework support does technically exist with Steeltoe. I relatively recently heard that ASP.NET Core 2.3 was released earlier this year, which was just a re-release of 2.1. But apparently .NET Framework is supported again. I'm super curious if anybody out there is interested in Steeltoe on this setup. Definitely do let us know if you are interested. We are extremely unlikely to go dive in and revisit this unless there is interest, because it's probably going to be a lot of work. Even just to get started with a .NET Framework on Core is a bit of a lift. And that's it for me today. We've got the Steeltoe accounts on the socials. I've been online for forever. You can find me. I'm not usually the loudest online. I'm too busy with my head down getting work done. but more than happy to engage on anything in general.
Awesome. All right, everyone. We have a couple minutes to spare. If you have questions for Tim about Steeltoe, now is the time. Drop them in the chat. I know Tim can see the chat, so yeah, drop your questions. Tim, while we give folks a moment, we have a lot of people asking about getting involved in projects. Is Steeltoe looking for help? Is it easy for someone to jump into Steeltoe as a first-time contributor?
You know, there's probably more that we could do to make it easy to get started. Honestly, with this 4.0 release, one of the areas that we kind of glossed over was some of the getting started guides that we have. So we have a whole host of getting started guides that were built for Steeltoe v3. So if somebody was interested in getting started, it might be interesting to actually try those getting started guides and see if you can figure out how to make them work with Steeltoe v4. We put more of our efforts into a more comprehensive guide that was like, if you're on this API, move to that API.
Yeah.
And something we have to come back around to is these guides. So that would be an interesting way to get to know the framework and help out.
Yeah, I think we always underestimate how much help documentation is to different projects. So that's a great point. If you're looking to get started on any project, not just Steeltoe, look at documentation. That's how I got my start, was just writing docs for different projects.
For real, it's definitely the easiest way to get started, and you'll find that a lot of OSS projects have a pretty small core team that aren't necessarily doc writers in their profession. And like we don't have a doc writer. We've never had a doc writer. So it's like what the engineers come up with. Like, I'm pretty good with the English language, but I'm not a doc writer. So anybody can help fix those issues.
Absolutely. All right. Well, I don't see any questions coming in, but everyone out there, you have Tim's information if you'd like to ask any follow-up questions afterwards. Tim, thank you so much for hanging out with us today.